Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the applications of the auxiliary planes method to evaluate the true shape and sizes corresponding to the inclined surfaces of the solid. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with the orthographic front view and the left hand side views of a given solid. Now as we observe the solid in the left hand side view, so we observe that we have got a face A, right? So this is the face A. It has got two surfaces over here. Top surface we are going to call as surface 1, and this bottom inclined surface we are going to call as surface 2 over here. So this complete inclined face happens to be face A over here. Now we are required to evaluate the true shape of this face A using the principles of the auxiliary plane method. Now when we observe the front view of the solid, so we can obtain the connectivity between the edge view corresponding to the surface 1, that is this edge view of the surface 1, it is corresponding to vertical surface, which is a rectangular surface. We can see it is a rectangular surface which we have got in the front view, and there is a angular slot which has been cut in this vertical surface of the solid. So we can say that here we have got this surface over here, starting from this point as we move along like this, and over here. So this is a rectangular surface having an angular slot. So corresponding to this surface A or the element 1 of this particular solid, we have been able to obtain the edge view of this particular surface in the left hand side view. Similarly, we have got element 2 or surface 2 which is lying on the inclined face A of this particular solid, and this particular edge view which is corresponding to the element number 2, it is going to represent the apparent shape of this rectangular surface which is appearing in the front view projections of this particular solid. Now there is another vertical element we can see which is appearing in the left hand side view. Now since this vertical element or the vertical edge of the solid, it happens to be parallel to the intermediate profile plane x1 y1 over here, so we are going to draw an intermediate reference plane x1 y1 over here. Now since this vertical edge, it will be parallel to the reference plane x1 y1, so this surface which is appearing as a big rectangle over here, it is already appearing as a true shape in the front view projections over here. So we have divided the solid into three elements. Element 1 which is having an edge view onto the left hand side view of, and it appears as surface 1 in the face A. Then you have the element 2 which is the lower rectangle over here, and this element again, because the edge view of this element has been obtained in the left hand side view, so we need to obtain the true shape of this rectangular surface of the solid. Then we have got the element number 3 which is a vertical edge. So vertical edge happens to be parallel to the profile plane or the x1 y1 reference plane. So here we have already obtained the true shape corresponding to this vertical edge which is available with us in the left hand side view. So now using this information, we are going to obtain the true shape corresponding to the surface 1 or the element 1, and true shape corresponding to the surface 2 or element number 2 of the solid. We are going to evaluate using the principles of the auxiliary plane. So what we are going to do, we are going to draw an auxiliary plane parallel to this face A, and the projections of all the points which are going to lie onto this particular edge view of the surface 1 and onto the edge view of the surface 2. So the projectors from these edge view projection points, they will be drawn onto the auxiliary plane, and these projections, they will be providing us with the auxiliary view projections, which will be giving us the true shape of the inclined surface of the solid. Let us proceed with the evaluation of true shape of these two surfaces which are lying along this particular surface A. So here we have got the front view orthographic projections as well as the left hand side view orthographic projections. Now we are going to draw the projector lines which are going to establish the relationship between the front view projections and the left hand side view projection. So in all, 1, 2, 3, 4, 5. So 5 horizontal projector lines we have drawn over here in order to evaluate the relationship between the corresponding points which are available with us in the front view and the points which are available with us in the left hand side view. Second thing, we have drawn the intermediate reference plane x1, y1, because in order to draw the auxiliary view projections, we need to evaluate the distances of all of these points which are appearing in the front view from the intermediate reference plane, that is x1, y1. So an intermediate plane which is x1, y1 has been plotted over here. Now we need to mark all the points in the front view which are going to define the different edges of the surface 1 and different edges of the surface 2 over here. So as we look at the surface number 1, so we can see that if we start in a clockwise direction from this point, so the first point, it will be 1 dash. Then as we move along this particular direction towards the right side, the second point which will be obtained will be 2 dash. Then next point in the sequence will be 3 dash, 4 dash, 5 dash, 6 dash, 7 dash and 8 dash over here. It means that 8 points, they will be required to define different edges corresponding to the surface which has been labeled as surface within the face A. So within face A, this is my surface number 1. So surface 1 can be defined by marking 8 points onto the front view orthographic projection. Similarly, this is my surface 2 or element number 2. So corresponding to element number 2, we have got an apparent shape which is appearing as a rectangular surface over here. So into this apparent shape rectangular section, we require 4 points to identify the shape of this apparent shape. So these 4 points, they happen to be 9 dash, 10 dash, 11 dash and 12 dash over here. So having marked all these 12 points in the front view, now I need to mark these points or obtain these points in the left hand side view. So as I am going to look at the solid from this direction, so we'll work out that the points 1 dash, 2 dash, 5 dash and 6 dash, they will be all lying in one line and they will be coinciding over here onto this particular point of the edge view. So in the edge view, we are going to obtain 4 points over here, which will be 1 double dash, 2 double dash, 5 double dash and 6 double dash. So 4 points we have obtained corresponding to these 4 points of the apparent view surface number 1. Now as we move along this particular direction corresponding to this projection line, points 3 dash and 4 dash, so they will be once again lying in the same projection line and they will be coinciding with each other. So their projection on the edge view will be marked as 3 double dash and 4 double dash over here. So this point we can mark as 3 double dash and 4 double dash. Similarly, corresponding to this projection line, so as we are going to look from this side, points 8 dash and 7 dash, they will be lying in the same projection line and they will be coinciding with each other and they will be marked as points 8 double dash and 7 double dash onto this particular edge view. Okay. So onto this edge view corresponding to element number 1 or surface number 1, which is going to lie on the face A, we have been able to obtain 8 points over here. So 4 points, they are lying on the topmost point of the edge view. 2 points they are marked on the bottom point of the edge view, and another 2 points they have been marked corresponding to this distance over here onto the edge view. So next we move on to location of the points which were defining the apparent view shape in the front view onto this left hand side view. So points 9 dash and 10 dash, so they are lying on the same projection line and they will be projected like this over here onto the edge view. So onto the edge view they will be again coinciding with each other, and they have been marked as 9 double dash and 10 double dash onto this edge view upper corner over here. Similarly, as we are going to look from this side, points 12 dash and 11 dash, so they will be again lying on the same projection line. So these points they will be coinciding with each other, and on the edge view these points will be located at the bottom point on the right hand side corner of the solid, and the names of these points will be 12 double dash and 11 double dash. So now we have been able to mark and evaluate all the 12 points which are lying onto the edge view of this particular solid, and these 12 points they corresponding to the inclined surface 1 and inclined surface 2, which form part of the face number A over here. Now what I am going to do, I am going to mark another auxiliary plane over here. This is my auxiliary plane x2 y2 which I have marked over here, and this auxiliary plane x2 y2 will be drawn in such a way that this auxiliary plane must be parallel to the orientation or the inclination of the face A over here. So this way, this plane x2 y2 auxiliary plane, it will be parallel to surface 1, and this auxiliary plane x2 y2 it will be parallel to the orientation of the surface number 2 over here corresponding to element number 2 of the solid. So whatever projections we are going to draw through these 12 points onto this auxiliary plane, they will be providing us with the true shape of the two surfaces, surface 1 and surface 2 over here. So let us draw the projections of all of these 12 points onto this auxiliary plane, and we find that since many of the points they are coinciding with each other, so corresponding to the 12 points, so we have been able to obtain projector number 1, 2, 3, 4 and 5. So only 5 projector lines they will be available, and we must ensure that all these 5 projector lines which are emerging from these points which are lying on the edge views over here, and these projector lines they must be perpendicular to the auxiliary plane. Now we are going to mark the distances of these 12 points in the front view from this reference plane x1 y1 over here, and once we evaluate the distances of all these 12 points from the x1 y1 reference plane, so all these distances they will be transferred in the auxiliary view and onto the auxiliary plane over here. So we are going to obtain the true shape of these two surfaces by projecting the distances between all of these points and the x1 y1 reference plane into the auxiliary view projections over here. So let us start with this. Now we can observe that there are 4 points, 6 dash, 7 dash, 10 dash and 11 dash. So we have been able to obtain these 4 points. They are appearing in one vertical line or as a one vertical edge in the front view projection, and this vertical edge it happens to be parallel to the x1 y1 reference plane. So once we measure the distance between this reference plane x1 y1 and this particular edge over vertical edge over here, so this distance we have marked as distance A1, because there was flexibility regarding the construction of the view and this particular x1 y1 reference line. So we do not have the exact measurement of this particular distance. So we have marked this distance equal to A1 from the x1 y1 reference line. So having evaluated the distances of the points 6 dash, 7 dash, 10 dash and 11 dash from the x1 y1 reference plane. So this distance A1, it will be plotted in front of the plane, that is ahead of the plane over here. So ahead of the plane, we are going to mark this distance A1 and one projection line parallel to the auxiliary plane x2 y2 will be obtained. And the moment I obtain this projection line parallel to the auxiliary plane x2 y2, now I will be able to locate the point 6 dash, 7 dash, 10 dash and 11 dash onto the auxiliary projection view. Now I can see this is the projection line corresponding to the point 6 dash. So as I move along this particular projection line onto the left hand side view, I have got the projection corresponding to the point 6 double dash over here. Now onto this projection line, if I mark a distance A1 ahead of this particular auxiliary plane, I will be able to locate my point 6,1 dash in the auxiliary elevation view over here. So the point 6,1 dash will be located ahead of the plane in front of this particular auxiliary plane into the auxiliary elevation view. Similarly, the second point, which is at a distance of A1 with respect to the reference plane x1 y1, it is 7 dash. Now as I move along this projection line, I am able to obtain this point 7 double dash. So now this projection line corresponds to point 7 or 7 double dash. So once I mark a distance of distance A1 alongside this projection line, I will be able to locate the projections of the point number 7, that is 7,1 dash in the auxiliary elevation view. Similarly, I have third point, which is at a distance of A1 from the x1 y1 reference plane, and the name of this point is 10 dash. So as I move along this projector line, so I am able to obtain this point 10 double dash in the left hand side view. So now the projector through this point 10 double dash, once I draw, if I mark a distance of A1 from this auxiliary plane, I'll be able to obtain the point 10,1 dash over here. Similarly, point 11 dash, it is at a distance of A1 from the x1 y1 reference plane. So once from this point 11 double dash, whatever projector I have marked over here, I need to evaluate and plot the distance of A1 alongside this particular projector line. And once I draw this distance, I will be able to obtain the point 11,1 dash. So the 4 points we have been able to obtain in the auxiliary elevation view. Now as we move further towards the left hand side surface of the solid, so the next point which will be encountered over here will be point 4 dash. So now I am going to mark this distance of point 4 dash from this x1 y1 reference plane. So please check, I have marked this distance of the point 4 dash from the x1 y1 reference line. So once I measure this distance, now I'll evaluate the location of the point 4 double dash in the left hand side view. So onto this projection line, if I mark a distance of A2, so this distance, please check, I have marked this distance A2 over here. So corresponding to A2, another horizontal projection line has been drawn. So onto this projection line, which is emerging from the point 4 double dash, I have to mark this distance A2 ahead of the plane. A2 in front of the plane or ahead of the plane. So this distance will be ahead of the plane. So this will give me the location of the point 4,1 dash. Now as I move along the left hand side direction starting from this reference plane, next point which will be encountered is point 5 dash. So now we see that this point 5 dash, it is at a distance of A3 from the x1 y1 reference plane. Now once I measure this distance A3, now corresponding to the projection line of the point number 5, which happens to be 5 double dash. So point 5 double dash lies over here. So onto this projection line ahead of the plane, I will be marking the distance A3 over here. The moment I mark this distance as A3, So I will be able to obtain the location of the point phi 1 dash onto this projector line, which is emerging from the point phi double dash on the edge view. Now, as I move along once again towards the left hand side, the next point which will be encountered is 2 dash. Now, using the similar notations, the distance of the point 2 dash from the x1 y1 reference plane will be marked as A4. Now, let me see, where does this point lie? It lies on the top face. So this point on the edge view contains the point 2 double dash, that is on the same projector line over here. As I move along ahead of the plane, I have to mark this distance equal to A4. So this distance should be A4 onto this projector line. So my next point 21 dash has been obtained, and then next point which will be available with me will be point 3 dash. So using same notations, the distance of point 3 dash from the x1 y1 reference plane happens to be A5. Now let me check where does point 3 lie. It lies at this location. So as I move along this projection line, I am able to identify the projector line corresponding to the point 3 double dash over here. Now it is this projection line. So alongside this projection line, now I need to mark a distance of A5. So please check, alongside this particular projection line, I need to mark the distance A5. So I mark this distance equal to A5. And once I mark this point over here, I am able to locate the location of the point 31 dash over here. And finally, I have got last 4 points: 1 dash, 8 dash, 9 dash and 12 dash. So we know that this vertical edge of the solid, it happens to lie at a distance of A1, which is this distance, plus 76 millimeter. So this total distance happens to be A1 plus 76 millimeter. This distance is A1, and this distance happens to be width of the solid, which is equal to 76 millimeter. So onto this projection line, I am able to obtain 4 points over here. So having measured this distance equal to A1 plus 76, let me mark this distance in the auxiliary elevation view. So in the auxiliary elevation view, we can see that this distance happens to be A1, and I have marked this distance equal to 76 millimeter ahead of this distance A1. So this way, I am able to draw one projector line over here, which will be again parallel to this x2 y2 auxiliary plane reference line over here. Now I am able to obtain 4 points: 1 dash, 8 dash, 9 dash and 12 dash points over here in the auxiliary elevation view. Now as we can see, point 1 dash lies on the top surface. So as we move along, we work out that point 1 double dash, it is located at the top corner of this particular inclined edge view, which corresponds to surface number 1. Now alongside this particular projector line, wherever I am able to mark the distance of A1 plus 76, this is A1, and this distance happens to be 76 millimeter. So this point will give me the location of 1 dash over here. Similarly, point 8 dash lies into this orientation. So as I move along, I obtain the location of the point 8 double dash over here, that is at the bottom point of this inclined edge view. Now as I move along this particular projection line, I need to mark the distance of A1 plus 76 millimeter alongside this vertical projector line, and here I get the location of 1 dash. Similarly, I have got the location of 9 dash at a distance of A1 plus 76 millimeter. So as I move along this projector, I am able to locate the location of the point 9 double dash in the left hand side view. So alongside this projector, as I move, I need to mark the distance as A1 plus 76 millimeter. So I have obtained the point 91 dash over here. Similarly, point 12 dash, it is also located at a distance of A1 plus 76. So this is the location of the projection line which corresponds to this point number 12, and alongside this projector line I need to mark this distance of A1 plus 76 millimeter. So I will be able to obtain this point 12.1 dash, and now we have been able to obtain the projections of all these 12 points which were available with us in the front view as apparent projections over here into the auxiliary elevation view. So we have developed the auxiliary elevation view. Once we join all these edges, we will be able to obtain the true shape of surface number 1, which corresponds to this edge view corresponding to element number 1 over here. So this was our element number 1. Similarly, if I join all the 4 points over here, I'll be able to obtain the true shape of this particular rectangular section over here. So the apparent shape was visible to me in the front view corresponding to the points 9 dash, 10 dash, 11 dash and 12 dash. So here in the auxiliary elevation view, I have been able to obtain the true shape of this rectangular surface. Now if we compare this true shape and this true shape with respect to the apparent view projections which we had obtained in the front view projections earlier, so this image or this cross section of the surface A, which was the apparent shape of this particular section of the solid over here, this is smaller than the true shape projections of the solid. So we observe that the true shape projections of surface 1, they happen to be bigger than the apparent shape projections of the surface 1. Similarly, the true shape projections of the surface 2, they happen to be bigger than the apparent shape projections of the surface which were obtained in the front view orthographic projection. So this is the complete procedure regarding the evaluation of true shape of an inclined surface of the solid. So I can also call these projections as auxiliary elevation projection. Why? Because over here we have used the distances of front view to draw this auxiliary view. So these are the auxiliary view projections or the auxiliary elevation projections which are able to provide us with the true shape of the face A. And the reason was because we had drawn an auxiliary plane over here x2 y2 parallel to the surfaces which were contained by face A over here. So surface 1, it was parallel to the auxiliary plane. Surface 2, it was parallel to the auxiliary plane. So we have been able to obtain the true shapes of both of these surfaces corresponding to the face A. So this is all for today. So we'll be continuing with few more illustrations regarding the applications of the auxiliary planes towards evaluation of the true shapes and sizes of the inclined surfaces of the solids. So thank you very much. Thanks a lot.